This is my beginning algebra course. Today we're going to use systems of equations to solve word problems. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. Now, I'd like to avoid word problems altogether in this course because word problems are really intimidating to students, and the primary objective of this course is not to learn word problems but to learn fluency in algebra. Unfortunately, we can't avoid word problems because they're such a big part of the general math curriculum. So you have to start getting used to word problems even at this elementary level. Now, there's an infinite number of word problems that we could cover in this course. In fact, we could make this course, or any course, a formal beginning algebra course or an online beginning algebra course, 10 times the size by simply covering word problems. So we don't have time to cover every type of variation of the word problems that are out there. So we're just going to pick some of the most important or most common types of word problems that you'll see at this level. And word problems that require systems of equations are some of the most common word problems that you'll see. So let's get into it. There are red bottle caps and blue bottle caps in a bag. There's a total of 56 bottle caps in the bag. There are 12 more red caps than blue caps. How many caps of each color are in the bag? Do you see what I mean when I say that these problems are intimidating? But don't worry about it. These problems aren't difficult. They're just intimidating when you first see them. Now, whenever you approach a word problem that requires a system of equations to solve, the first thing that you want to ask is, what are your variables going to represent? And that's very easy to figure out. In order to figure out what your variables are going to represent, you simply figure out what is the problem asking. How many caps of each color are in the bag? That's the first step. So first step. So we're going to let R be the number of red caps, and we'll let B equal the number of blue caps. So again, that's the first step, and it's the most important step. I guess I don't really have to write step for the title. So again, that's the most important step, and it's the first step. I require that you do this in every problem. You have to define variables. All right, and the second thing we're going to do is we're going to find the easiest equation. For most of these problems, there's going to be one equation that's really, really easy. And that equation is going to be generated by this sentence. There is a total of 56 bottle caps in the bag. So that means the number of red bottle caps plus the number of blue bottle caps is equal to 56. So that's a really easy equation. That's based on the blue sentence. And notice I have my bracket here because I'm starting to make a system of equations. So those first two steps are the easiest step. They're not difficult. So even though this problem may seem very intimidating, again, those first two steps are easy. So if you want to complain about these problems, that's okay, but you can't complain until you do these first two steps. After you do those first two steps, then you can say, okay, well, now it's going to become difficult because the next sentence, there are 12 more red caps than blue caps. That sentence does take a little practice to write as an algebraic equation. So again, you want to do the first two steps first, and then we can worry about the hard part. So now there are 12 more red caps than blue caps. So that means R is equal to 12 plus B. That's the hard part. And the reason that that's the hard part is because a lot of students will say B is equal to 12 plus R. It's very common to make that mistake. So if you get the wrong answer, just be aware that that could be the source of your error. So how do we know which equation is correct? Well, we have to have more red caps. So if you take the number of blue caps and you add 12, that means that the number of red caps is obviously going to be more than the number of blue caps. So that takes some practice to understand. So now at this point, all we have to do is solve this system of equations, and then we'll be done. So in this system, we see that one of the variables is isolated. R is isolated. So if you remember back to your your class on solving systems of equations, we learned two methods for solving the systems. We may learn a third method depending on the order of the classes here, but in that first class we learned two methods, substitution and elimination. When you have a variable that's isolated by itself on one side of the equation, you want to use substitution. So we're going to take the other equation and we're going to rewrite it, but instead of r, we're going to write 12 plus b. So instead of this r value here, we plugged in 12 plus b. And then we're just going to add the b's together. So b plus b is 2b. And then it just becomes a two-step equation. Subtract 12 from both sides and divide by 2. And you get b is equal to 22. And that's one of the answers. So there's 22 blue caps. And then we use the other equation. We could use the blue equation, but the green equation is going to be the easiest to use to find the number of red caps. And then we just plug in 22 for the number of blue caps. And r is equal to 34. So there's 34 red caps. So those are the answers. So that's how you use a system of equations to solve a word problem. So let's try one together, one more together before you try one on your own. There are 3 times as many, well, I don't even need to write it really. First we just start with defining our variables. So what are our variables going to represent? Well, whatever the problem is asking, that tells us what our variables are going to represent. So how many of each type of animal are there? So there's mules and horses, so I'm going to let h equal the number of horses, and I'm going to let m equal the number of mules. So that's the first step. Again, if these problems seem intimidating to you, that's okay, that's normal, but don't complain until you do these first steps, because these first steps are not difficult. Defining variables is not difficult. All right, now we're going to make our system of equations, and we're going to look for the easy equation first. The easy equation is actually the second sentence. The difference between the number of horses and mules is 12. So horses comes first in the sentence, so we write h minus m is equal to 12. Remember, difference means subtraction. You have to remember that. Difference means subtraction. So h minus m is equal to 12. The number of horses minus the number of mules is equal to 12. So that was the easy equation. So that was the second step. Again, you need to do those two steps first before you start complaining about the difficulty of these problems. Now when we get to this sentence, there are 3 times as many horses as mules. You can complain if you want to, because that's the hard part. So there are 3 times as many horses as mules. So that means h is equal to 3m. Now again, a lot of students will say m is equal to 3h. That's a very common mistake. M is equal to 3h doesn't make sense, because what the green sentence is telling us is that there are more horses than mules. There are 3 times as many horses as mules. So if you take the number of mules and multiply by 3, you get the number of horses. So that means the number of horses is going to be bigger than the number of mules. So this bottom equation down here doesn't make any sense. Again, if you're going to make a mistake, that's probably where it's going to be. All right, so h is solved for. You see how h is isolated. It's by itself on one side of the equation here. So that means we're going to use substitution. We're going to use substitution for a lot of these first problems. So we take the other equation where the variable is not solved for, and we rewrite it, but instead of h, we're going to write 3m, because we know h equals 3m. And then 3m minus 1m is 2m, and divide both sides by 2, and we have the number of mules is equal to 6. Now we take the other equation, just because that's the easiest one to use at this point. The number of horses is equal to 3 times the number of mules, and we know the number of mules is 6 because we just figured that out. 3 times 6 is 18, so the number of horses is 18. And there we go. So now it's time for you to try. I'm going to leave those problems in the window. And remember, these problems can be very, very intimidating. But don't complain about that until you do those first two steps. When you do those first two steps, you're going to feel more confident to do the hard part of the problem. So try number 3, and when you come back, we'll do it together. All right, we're back. So how many of each type of card does he have in his pocket? So we're going to let B equal number of baseball cards. This should be your first step. If you didn't do this part, you need to go back and do it. F will be the number of football cards. You have to define variables. That's the first step. If you didn't do that, go back and do it and redo the problem. Number of baseball cards, number of football cards. So now we look for the easy equation. Billy has 21 cards in his pocket. That's the easy equation, because that just means the number of baseball cards plus the number of football cards is equal to 21. Very, very easy. So those are the first two steps. That was the easy part. Now we go to the hard part. There are 5 fewer football cards than baseball cards. So that's the hard part. There are 5 fewer football cards than baseball cards. So that means the number of football cards is going to be equal to the number of baseball cards minus 5. It's very easy, very, very easy to accidentally say B is equal to F minus 5. But that's not correct, because it's saying that there are fewer baseball cards. Wait, no, fewer football cards than baseball cards. So the number of football cards should be less than the number of baseball cards. So if you take the number of baseball cards and subtract 5, then you get F, which means F should be smaller. That's what the problem is saying. Again, if you made a mistake, this is probably where you would make that mistake. All right, so that's the hard part there, making that equation. So now we just have to solve the system. So we're going to use the blue equation, and we have B plus B minus 5 is equal to 21. So we just plugged in B minus 5 for F in the top equation. B plus B is 2B, and that's a two-step equation now. Add 5 to both sides and divide both sides by 2, and you get 13. So he has 13 baseball cards. Now we use the green equation. Again, we could use the blue equation, but we're just going to use the green because that's the easiest one to use, because the number of football cards is already isolated. F is already isolated. So that would be 13 minus 5. Number of football cards is 8. 8 football cards. So if you got those answers, good job. Now, one quick and easy way to check your answers is to plug in 8 and 13 into the blue equation. 8 plus 13 should be 21, and it is. And of course, if you really want to be thorough in your check, you would check with this equation, but technically we already did that math, so we don't have to worry. All right, again, if you got those answers, good job. You're on the right track. Now, if you got the wrong answers, that's okay. These problems take a lot of practice, so we'll try another one. I'll leave that problem in the window. Try number 4. And when you come back, we'll do it together. All right, we're back. How many of each dessert are there? That's the first step, is to define the variables. So we have cookies. We'll let C equal the number of cookies. And B will be the number of brownies. That's the first step, and the most important step. If you didn't do that step, go back and do it. The easy equation is going to be generated by this sentence. The difference between the number of cookies and the brownies at a bake sale is 40. Now, in the sentence, cookies comes first, so that's going to be it's going to be C minus B is equal to 40. Don't do B minus C. It's got to be C minus B. C's got to come first because cookies comes first in the sentence. All right, so that was the easy equation. And the hard equation is there are twice as many cookies as brownies. twice as many cookies as brownies, so the number of cookies equals 2 times the number of brownies. Again, that's the hard part. So now we just solve the system of equations. Plug in 2b for c in the top equation. And 2b minus b is equal to b. So there are 40 brownies. And the number of cookies is equal to 2 times the number of brownies. So the number of cookies is 80. So if you got those two answers, good job. So number 5 is the same type of problem, but the difficulty equation is going to be a little bit more complex. So let's do this first one together. The first step is figure out what the problem is asking. How many Democrats are at the meeting? Now this is different because we don't have to find both variables. We're only looking for one of the variables. So be aware that in some of these problems, you're only looking for one of the variables, but we do have to define both variables to solve this system. So we're going to let D equal the number of Democrats, and R is going to be the number of Republicans, obviously. And let's look for the easy equation, see if you can find the easy equation. There are 18 people at a government meeting. So that's the easy equation. So the number of Democrats plus the number of Republicans is equal to 18, obviously. And here comes the hard equation. If the number of Republicans is 2 more than 3 times the number of Democrats, that's the hard part. So the number of Republicans, R, equals, a lot of times in math means equals, is 2 more than 3 times the number of Democrats. So that would be R is equal to 2 plus 3D. That's what that sentence means. If the number of Republicans is 2 more than 3 times the number of Democrats. Now again, a lot of students are going to write something like this. They'll switch the variables. So that's a common source of error. So again, this problem is a little more complex because this green equation was more complicated. So we're going to look at the blue equation as usual, and we're going to rewrite the blue equation, but instead of R, we're going to write what R equals. Now, D plus 3D is 4D. And now we have a two-step equation. Subtract 2 from both sides, divide both sides by 4, and we get D is equal to 4. There's 4 Democrats at the meeting. Now, we can actually stop there because, remember, we're only looking for the number of Democrats. Whoops. We're only looking for the number of Democrats. So we found the number of Democrats. We don't have to find the number of Republicans. So, again, there's 2 differences with that problem. Number 1, this green equation was a little bit more complicated, and also we're only looking for one of the variables. So the next problem is going to be similar to that problem. So I'll leave number 5 in the window and go ahead and try number 6, and when you come back, we'll do it together. All right, we're back. So the first thing we need to ask is what is we have to define our variables. How many girls are there? So G is going to be the number of girls, and obviously B is going to be the number of boys. And I guess technically I should only highlight that. I shouldn't highlight the one we're not looking for. But again, it doesn't really matter as long as you know how to solve the problem. All right, so now we look for the easy equation, and that's there are 34 students in the classroom. Now here comes the hard equation. The number of boys is 8 less than 2 times the number of girls. So B equals 2G minus 8. So that was the hard equation. So now we just solve. So we take the blue equation as usual, and instead of B, we're just going to rewrite the blue equation, but instead of B, we're going to write 2G minus 8. And I'm sorry that my G's look like 6's. All right, G plus 2G is 3G. And now we have a two-step equation. add 8 to both sides, divide both sides by 3. So the number of girls is equal to 14. So we have 14 girls. Now, again, we don't have to figure out how many boys there are because the problem is not asking for how many boys. It's asking for how many girls. So that would be our final answer. So if you got that answer, good job. So now we're going to move on to money problems. So we'll do the first one together. A guy at a theme park sells cotton candy and salted pretzels. He sells cotton candy for $6 each and pretzels for $7 each. In one day, the man made 38 sales, totaling $235. How many of each item did he sell? So I know this looks intimidating, but remember the first thing that we need to do is simply define our variables. Don't let yourself be intimidated until you define those variables first. After you define the variables, then you can worry about the difficulty of the problem. So how many of each item did he sell? So let C equal the number of cotton candy. I guess we can call them cotton candy sticks. I don't know what they would be called. And we'll let P be the number of pretzels. All right, and let's see if we can... The easy part of the equation is actually going to be the man made 38 sales. So that means he sold a certain number of pretzels, a certain number of cotton candy sticks, but the total, if you add those numbers up, you get 38. So one sale would be like selling one pretzel, and if you do another sale, that would be like selling one cotton candy stick, so on and so forth. So our system of equations is going to start with the number of cotton candy sticks plus the number of pretzels that he sold is 38. That's what it means by sales. So that's the easy equation. Now we go to the harder equation. This is the equation that's going to cause some anxiety in students. He sells cotton candy for $6 each and pretzels for $7 each. And his total sales, the amount of money that he took in was $235. So this is the hard equation. So please pay attention with this. So to explain this, I'm going to write 6 times C is the amount of money he collected from the cotton candy sales. And that's because C is the number of cotton candy sticks that he sells. And obviously, if he sells cotton candy sticks for $6 each, you take 6 and multiply it by C. Remember, when you put a number next to a letter, that's multiplication. And 7 times P is the amount of money he collected from the sales of the pretzels. I'm running out of room, so I'm going to have to make that smaller. So if we add up, if it's $7 for each pretzel, then you take $7 and multiply it by the number of pretzels he sold, and that gives you the amount of money that he made from selling the pretzels. So if you add up the amount of money he made from selling cotton candy and the amount of money he made from selling pretzels, you should get $235. Again, this is the difficult equation that students are going to have trouble with. Actually, sometimes students have trouble with the blue equation and they figure out the green equation easily. It just depends on how you're thinking about the problem. Again, if it's $6 for each cotton candy stick, then you take the number of cotton candy sticks and you multiply by 6, and that gives you the total amount of money from cotton candy, and same thing with pretzels. So now we have a system of equations as usual, but for this system we're not going to use substitution. And the reason we're not going to use substitution is because there's no variable isolated here. There's no variable by itself on one side of the equation. So we're going to have to use elimination. So for elimination, we can eliminate C or we can eliminate P. So which one do you want to eliminate? Well, I'm going to eliminate C. So I'm going to multiply the top equation, the blue equation, by -6. And I'm going to use distribution because I'm multiplying by a sum. So -6 times c is -6c. -6 times p is -6p. And 6 times 38, you can use your calculator for that. 6 times 38 is 228. So we have -228. And now we're ready to eliminate, because when you add these c's, they're going to cancel out, or they're going to eliminate. So -6p plus 7p is 1p, and -228 plus 235 is 7. So it looks like he sold 7 pretzels. And if you use the blue equation, which we really don't have a lot of time, or a lot of space, that is, it would be c plus 7 pretzels is equal to 38, and subtract 7 from both sides, and we get c is equal to 31. So he sold 31 cotton candies. So it looks like the cotton candy sticks were more popular than the pretzels. Now I want you to be aware that I'm not going to show this in each step. I'm just going to show the result. So I'm going to skip this step just because I don't want to have to rewrite this over and over and over again. So I'm just going to go here to here. So be aware of that as we do these next problems, because as you can see, I'm kind of running out of room. And I'm not going to write this every time because it's just going to take too long. So hopefully you understand why 6c is the amount of money he collected from selling cotton candy, and 7p is the amount of money he collected from selling the pretzels. And you add that together and you get 235, which is the amount of money he collected total for all his sales. So let's do one more of these problems before you try one on your own. At a play, the price of admission for an adult is $25, whereas the price of admission for a child is $15. Sometimes they charge different fees, or different entrance fees for kids and adults. The theater sold 86 tickets and received $1,910. How many of each type of ticket did the theater sell? So obviously, as usual, we're going to start with defining the variables. That's the most important part, and that's that's the easiest part, because it tells us how to define the variables. How many of each type of ticket did the theater sell? So we're going to let A equal the number of adult tickets, and we're going to let C equal the number of child tickets. So again, that's the easy part. And now we're going to look for the easiest equation, and that's going to be the theater sold 86 tickets. So the number of adult tickets plus the number of child tickets is equal to 86. And now we go to the hard part. So it's $25 for an adult ticket and $15 for a child ticket, and the total amount taken in is $1,910. So again, this is the hard part. That's going to be 25A plus 15C is equal to 1,910. That's the part that students are going to be a little intimidated by. Again, 25A, you take the number of adult tickets that are sold and you multiply by $25, because it's $25 for each ticket. That's this very, very simple logic. If you're selling tickets and you're selling 2 types of tickets and there's a different price, you know how to figure out how much money you're making. It's not difficult to understand. When you put a number next to a letter, that's multiplication. So number of adult tickets times 25, because it's $25 for each adult ticket. Number of child tickets times 15, because it's $15 for each child ticket. You add all that money up and you get the total amount of money that was taken in. I know that's a lot to think about, but it's just common sense. If you're selling the tickets, and you'll figure it out in about 2 seconds, because you want to know how much money you're going to make. But if you're doing algebra, it's kind of hard to get motivated to figure it out. But that's how you write. Again, the algebra is intimidating. Writing it on paper is intimidating, but doing it in your head is easy. If you're making money from selling these tickets, and you can figure that out in about 2 seconds. It's putting it down on paper with the algebraic language that is intimidating. All right, so again, we have to use elimination because there's no variable isolated. So I'm gonna get rid of C. I'm gonna eliminate C this time. So I'm gonna multiply both sides of the top equation by -15. And again, I'm not going to show that step because it would just make this class too long if I have to show that every time, the distribution. 15 times 86. You can do that on a calculator. And we get negative 1,290. And we just rewrite the bottom equation. In fact, I should be color coding these. Sorry about that. Just makes it easier to see which equation is which. Whoops, sorry. So we're just rewriting the bottom equation. We're not doing anything to that equation. So now we're ready to eliminate. So we add the equations together. The 15s cancel out. Negative 15a plus 25a is 10a. And add these two numbers together. You can use a calculator for that if you want to. I think that's going to be 620. And then we just divide both sides by 10, and we get 62. So the theater sold 62 adult tickets. Now we can use the blue equation. We can really use either of the equations, but the blue equation is going to be the easiest. So 62 adult tickets plus number of child tickets is equal to 86. So we just subtract 62 from both sides, and it looks like it's going to be, I think that's 24 child tickets. Right, and then to check that, we just add 62 with 24, and we should get 86, and we do. So those were examples of money problems where you have to use money, and another difference was that we had to use elimination in these problems. So in the next two problems we're going to do, you're going to deal with money, and we're going to use elimination to solve those systems of equations. So you can take a screenshot of these if you want, because we're going to go on to the next problem. And I want you to try number 9. These two, 9 and 10, are going to be the same type of problem. So go ahead and try number 9, and when you come back, we'll do it together. All right, we're back. How many of each size were sold? So I'm going to let S equal number of small hamburgers, and L obviously is going to be the number of large hamburgers. So again, that's the most important part of all these problems that we're doing today, is to define those variables. If you don't do that part, you might as well just quit. That's absolutely necessary to solve the problem, or else you're going to go nowhere. And so now we come up with the easy equation. Is there an easy equation? 46 hamburgers. That's the easy equation. So number of small hamburgers plus a number of large hamburgers that they sold is 46. Now we do the hard equation. That's going to require this information and also the amount of money that they made. So that's going to be 4s plus 5l is equal to 219. So we're going to you can eliminate s or you can eliminate l. You're going to get the same answer no matter which one you eliminate. I'm going to eliminate s, so I'm going to multiply the top equation by -4. And I'm using distribution there. I'm just not showing it. So 4 times 46 is equal to 184. Make sure you write a negative. It's negative 184. And then just rewrite the bottom equation. So now we're ready to eliminate. And we get L is equal to, let's see, that would be 35, it looks like. 35 large hamburgers. And we have to figure out how many small hamburgers. So use the blue equation, just subtract 35 from both sides. And it looks like there were 11 small hamburgers that were sold. So if you got those answers, good job. Let's try another one of those problems. Try number 10, and when you come back, we'll do it together. All right, we're back. So first step, as usual, define the variables. How many of each did he sell? So W is obviously going to be the number of whistles, and H is the number of hats. Let's see if we can find an easy equation. He makes 32 sales. That's the easy part. So the number of whistles that he sells plus the number of hats that he sells is equal to 32. And 2W plus 3H is equal to 77. We'll use elimination. Again, you can eliminate W or you can eliminate H. I usually go with the smaller number, so I'm going to eliminate W. All right, so now we're ready to eliminate. Again, I multiplied both sides of the blue equation by -2. And we get H is equal to 13. So there's 13 hats that he sold. Subtract 13 from both sides, and we get 19 whistles. He sold 19 whistles. So if you got those answers, good job. Now these next problems are going to be different because what they're asking for is the price per item. So in all the previous problems that we did, they're asking for the number of something. For example, the number of small hamburgers and large hamburgers, the number of whistles and the number of hats, the number of baseball cards, the number of football cards, the number of cookies, the number of brownies, so on and so forth. But this problem is not asking for that. It's not asking for the number of tacos that were sold. It's not asking for the number of quesadillas that were sold because they actually give us that information. They say 3 tacos and 2 quesadillas. And in the other sentence, it's 4 tacos and 1 quesadilla and so on and so forth. So we're not looking for that information. So this is changing. This is different. In this problem, they're looking for the price per item. So in the previous problems, we were given the price per item. And we're asked to find the number of each item sold. But in this problem, we're given the number of each item that's sold. And we're asked to find the price per item. So a very important difference here. So T is going to be the price per taco. And Q is going to be the price per quesadilla. So now let's make our system of equations, and this is going to be quite different. Now we usually look for an easy equation. In this case, there's not really an equation that I would consider to be an easier equation. They're both about the same difficulty level. So the first equation is going to be Dorian bought 3 tacos and 2 quesadillas for $14. So 3 tacos and 2 quesadillas for a total of $14. So we did this type of equation before, but now T and Q are the price per item. So you take the number of tacos that were sold, 3, and you multiply it by how much each taco costs. Again, it's the reverse situation. You take the number of quesadillas, the number of quesadillas, 2, and multiply by the price per quesadilla, and that total amount should give you the amount that they took in for that day, which is $14. And now we go to the other sentence. Lisa bought 4 tacos and 1 quesadilla for $12. So 4 tacos and 1 quesadilla for $12. So now we just solve that system. And the easiest way to do this is to multiply the bottom equation. In all the problems that we did before, we're multiplying the top equation, but now we're going to multiply the bottom equation because we can just get a -2 here. And if we do it that way, we're only going to have to multiply one equation. If we try to eliminate T, we're going to have to multiply both equations. So we want to eliminate Q in this system. So we're going to multiply the bottom equation. Well, first let's rewrite the top equation because that's not going to change. And we're going to multiply the bottom equation by -2. Now do you see why we did that? We did that because now we have 2Q and -2Q, so they're going to cancel out. And so we're ready to eliminate. So we add those equations together. 3t plus -8t is -5t. And the q's cancel out, and 14 plus -24 is a -10. and divide both sides by -5, and the number of tacos is 2. That's the price per taco. So $2 per taco. So I'm going to go ahead and write the units for this so we understand exactly what we're finding. So it's $2, put a dollar sign, per taco. Be sure to write the units when your variables are price per item. Now we have to find the price per quesadilla. We can take either of these equations. I'm going to take the purple one. That's going to be a little easier, and we can just plug in 2 for t. Whoops. So 4 times 2 plus price per quesadilla, which is what we're looking for. And that 4 times 2 is 8. And subtract 8 from both sides. I guess I can leave more room there. And we get the price per quesadilla is $4 per quesadilla. So again, that problem is very, very different because we're looking for the price per item, not the number of items that were sold. So it's a very important distinction. Let's try another one of these before you try one on your own. A school bought 4 soccer balls and 3 footballs for a total of $135. A different school bought 5 soccer balls and 2 footballs for a total of $132. What was the price per item? So again, we start by defining variables. And what are the variables going to be defined as? Well, that's just what the problem is asking. So what was the price per item? So we're going to let S equal the number of soccer balls, or actually S is going to be the price per soccer ball. And F is going to be the price per football. Now we generate our system of equations. 4S plus 3F equals 135, and 5S plus 2F equals 132. Now this problem is going to be different because in order to eliminate, we're going to have to multiply both equations. Now I'm going to eliminate F because these numbers are smaller than the 4 and the 5. Again, in this problem number 11, we only had to multiply one equation. We multiplied the purple equation. But in this problem, and I should color code, in this problem we're going to have to multiply both equations in order to eliminate. So in order to eliminate F, I'm going to multiply the top equation by -2, and the bottom equation I'm going to multiply by 3. Now you might be wondering, can you multiply the bottom by a negative and the top by a positive? That's fine, as long as one F term is negative and the other F term is positive. Again, this is all review from the class on systems of equations. So that looks right. Just checking the calculations there. Now we're going to eliminate. And -8s plus 15s would be 7s. The f's cancel out. And you can do that on the calculator if you want. 396 minus 270 is 126. Divide both sides by 7 and we get s is equal to 18. So the price per soccer ball is $18. Again, you need to put your units. $18 per ball. And we can use either of these equations to find the price per football. I'm going to use the bottom equation. So 5 times 18 plus 2f is equal to 132. We're just plugging in the $18 for this per soccer ball. And 5 times 18 is 90. And then we have a two-step equation. Subtract 90 from both sides. And divide by 2, and we get 21. $21 per football. So again, in these problems, we're looking for the price per item. So go ahead and take a screenshot of these problems so you can refer back to them. And now you're going to try some of those problems on your own. So go ahead and try 13. And when you come back, we'll do it together. All right, we're back. What was the price per game? We'll let the Mega Mice game be M. That's price per Mega Mice game. And E will let be the price per Earthman game. All right, now we can generate our system of equations. 5 Mega Mice games and 6 Earthman games. Total is $140. And that would be the green equation. And the next day, 8 Mega Mice games and 2 Earthman games for $110. So in this equation, we're only going to have to multiply in this system, we're only going to have to multiply one equation. We can multiply the bottom equation by -3, because that will give us a -6 here, and then we can eliminate the e's. So I'm just going to rewrite the top equation. In the bottom equation, we get -24m minus 6e equals -330. All right, so now we're ready to eliminate. And we get -19m is equal to -190. Divide both sides by -19, and we get 10. So each Mega Mice game cost $10. So be sure to put your $, $10 per game. Technically, it'd probably be better to write $10 per Mega Mice game, but I don't really want to, I don't have the time to write that. Okay, so we can use one of these equations to find the price per Earthman game. I'm just going to use the bottom equation. So 8 times 10 plus 2e is equal to 110. That's, well, 8 times 10 would just be 80. Two-step equation, subtract 80 from both sides. And we get 30 divided by 2, and we get $15. So $15 for each Earthman game. Now you're probably thinking that's not realistic. Video games cost more than that. Well, that's true, but these are used video games. We'll just say these are used video games. If you buy them used, you can get them a lot cheaper. So if you got those answers, $10 for the Mega Mice game and $15 for the Earthman game, good job. But notice we only had to multiply one of these equations to eliminate. In the next problem, you're going to have to multiply both equations to eliminate. So try number 14, and when you come back, we'll do it together. All right, we're back. What price did he charge per item? So D is the price per delicious bar. And S is the price per sour stick. And now we can generate our system of equations. 11 delicious bars and 5 sour sticks for $43. And the next day he sold 2 delicious bars and 3 sour sticks for $12. So as you can see, we have to multiply both equations to eliminate here. So I'm going to eliminate, I think I'm going to eliminate S. You can eliminate D also, but I'm going to eliminate S. So I'm going to multiply both sides of the top equation by -3, and both sides of the bottom equation by 5. Then we get -23D is equal to -69. Divide both sides by -23, and we get 3. So each delicious bar cost $3. Alright, we can use one of these equations. We can use either one. It doesn't really matter which one we use. Just choose the one that looks simpler. Plug in 3 for D. And we get 6 plus 3S is equal to 12. It's a two-step equation. Subtract 6 from both sides. Divide by 3, and you get S is equal to $2 per sour stick. Again, technically you should be writing sour stick and delicious bar, but I don't really have time to do all that. So if you got those answers, good job. All right, on to number 15. So again, the difference in the first problems we did, we were looking for numbers of things. And the last 4 problems we did, we were looking for the price per thing. Now we're going to go on to the same types of problems. There's no difference whatsoever, except we're using decimals now. We'll do this first one together. So how many stickers did he buy and how many pins did he buy? So we're looking for how many things in this problem. So S is the number of stickers, and P is the number of pins. And we'll generate our equations. So the easy equation is he bought 8 items. So the number of stickers plus the number of pins would be 8. And stickers were $1.19, so on and so forth. So again, this is the same type of problem, except we're dealing with decimals. So $1.19 for each sticker. So $1.19 S times S plus $3.13 times P, and you add all that money up and you get $19.22. So we're taking the number of stickers and multiplying by the price per sticker. That's the amount of money he paid for stickers. Taking the price per pin and multiplying by the number of pins, and that gives you the money he paid for pins, and you add all that up and it's a total of $19.22. Same problems we were doing before, except we just have decimals. Now, in these problems, these decimal problems, you can use a calculator. That's fine. In fact, I encourage you to use a calculator because it's just going to be too tedious if we try to do the arithmetic. So we're going to use elimination. I'm going to eliminate S, multiply both sides of the top equation by -1.19. So we can get the calculator out for that. And then just rewrite the bottom equation. And we're ready to eliminate. So add them up. And again, you can use a calculator for this stuff. 3.13 minus 1.19. That gives us 1.94p. And then 19.22 minus 9.52 gives us 9.7. And if we divide both sides by 1.94, and you can see that he bought 5 pins. I guess we don't really need to write pins because we already know P is equal to the number of pins. Then you can use the blue equation, plug in the number of pins. You can see that he must have bought 3 stickers. So again, that problem is the same thing we've been doing before, except we add decimals. So you can use a calculator on these problems. So now you try number 16, and when you come back, we'll do it together. All right, we're back. So J is number of pounds jerky, and P is number of pounds potatoes. And now we can generate our system of equations. So let's look for the easy equation first. He bought a total of 5 pounds of these items. So the number of pounds of jerky plus the number of pounds of potatoes should be 5. That's the easy equation. And beef jerky was $6.15 per pound, and potatoes were $3.08 per pound, totaling $21.54. All right, so we can eliminate P or J. So I'm going to eliminate P, so I'm going to multiply the top equation by negative 3.08. And again, you can use a calculator. And we're just rewriting the bottom equation. So now we're ready to eliminate. So again, you can use your calculator for this if you want. 6.15 minus 3.08 is 3.07J. The P's cancel out. And 21.54 minus 15.4 is 6.14. Divide both sides by 3.07. And he bought 2 pounds of jerky. I guess we can just say 2 pounds of jerky, just to be specific. All right, so obviously if you bought 2 pounds of jerky, he bought 3 pounds of potatoes. So if you got those answers, good job. On to number 17. These are decimal problems also. So let's try number 17. Natalie purchased 8 boxes of tissue and 5 rolls of paper towels for a total of $13.92. And I don't really need to read all this. What was the cost per box of tissue and the cost per roll of paper towels? So B is going to be the price per box of tissue. And R will be the price per roll of paper towels. So in this problem, unlike the previous 2 problems, in this problem we're looking for the price per item. In the previous 2 problems we were just looking for how many of something. So now we generate our system of equations. 8 times B plus 5 times R is equal to 1392. And 4B plus 2R is equal to 6.52. Again, there's no easy equation on this one. So in this one, we just have to multiply the bottom equation by negative 2 to eliminate B. That's the easiest way to do it. So I'm just going to rewrite the top equation. And the bottom equation multiplied by negative 2, we get negative 8B, negative 4R, and 2 times 6.52. That would be negative 13.04. and eliminate. Add the equations together, and we get R is equal to 0.88, and we need our units. Our units are dollars. Per box, or actually per roll. And we can use either of these equations. Plug in R. And 2 times 0.88. That would be 1.76. Now we have a two-step equation, but it's just decimals. So it's no different from the other two-step equations we're doing. We just have to use decimals. So subtract 1.76 from both sides. And then divide both sides by 4. You get 1.19. So $1.19 per box of tissue. That's B. So I can move that down a little bit. All right. So now you try number 18. I'm going to leave that in the window. And when you come back, we'll do it together. All right, we're back. So what are we looking for? What is the cost per brush and the cost per canvas? So B is the price per brush, and C will be the price or cost per canvas. So those are our two equations. And in this case, we have to multiply both equations by something, so this is going to be a little bit more difficult than problem 17. So I think I'm going to eliminate C, so multiply both sides of the top equation by -4. And again, you can use your calculator. And the bottom equation we have to multiply by -5. Actually, I'm sorry, not -5, just +5. Add those equations together. And we get 23B is equal to 186.3. Divide both sides by 23 and we get 8.1. So the price per brush is $8.10. Now I can plug it into one of these other equations. And you don't need the 0. Again, you can use your calculator for this stuff. And we get price per canvas is $4.25. So that was kind of a harder one than the previous one because you had to multiply both equations. So if you got those answers, good job. All right, we're going on to coin problems now. So I'll try a couple of these coin problems together before you try one on your own. A change machine contains nickels and quarters. There are a total of 36 coins. The total amount of money in the machine is $5.60. How many of each type of coin are in the machine? These are very common problems, so you're going to need to know how to do these coin problems. But they are kind of unique, so we need to get used to these. First, let's write what our variables are going to be equal to. How many of each type of coin are in the machine? So we'll let n be the number of nickels. So we're counting things. We're not counting price per thing. We're just counting things. Q is going to be the number of quarters. We're counting numbers of things, not price per thing. All right, we got the first step done. So now we have an easy equation. There are a total of 36 coins. That's a really easy equation. So the number of nickels plus the number of quarters is equal to 36. They're all coins. Nickels and quarters are both coins, but they have different monetary values. So we got the easy equation done. Now here comes the hard equation. The total amount of money in the machine is $5.60. Now we can write this equation in units of dollars, or we can write it in units of cents. It's easier to write it in units of cents. At least that's the way most students prefer. So I'm going to write it in units of cents. So we take each nickel is worth 5 cents. Now you need to know what nickels are worth and dimes and quarters. Nickels are 5 cents, dimes are 10 cents, and quarters are 25 cents, because we're going to do dimes in another problem here. We're not doing dimes now. So we take the value of each nickel, which is 5 cents, and multiply it by the number of nickels. And that's how much money comes from the nickels. So this problem is very similar to a previous problem that we did. And 25 cents for each quarter, so we take 25 cents and times it by the number of quarters, and we get the amount of money from the quarters. And you add up all that money, the money from the nickels and from the quarters. Sorry, I'm just waiting for my computer to catch up here. Add up the money from the nickels and the quarters, and they tell us that should be... Now this is the part where you really need to pay attention here. We're not going to write $5.60 because we're counting in units of cents. So it's not going to be 5.60, it's going to be 560 because we're counting in cents. Now you could do it in terms of dollars, but then you would write 0.05N and 0.25Q equals 5.60. If you wanted to write in units of dollars, that's what your equation would look like. But students really don't like to use decimals if they don't have to, so we're not going to do it that way. Now, why did the 5.60 turn into 560? Well, there's 100 cents in each dollar. You should know that. You can just look that up on the internet if you don't know if you haven't dealt with money yet. So each dollar is 100 cents. So obviously if there's $5, that's 500 cents. And then this is 60 hundredths of a dollar. So if each dollar is 100 cents, obviously that would just be 60 cents. If you're not really sure about the logic about that, then that's okay. Just memorize. You multiply you take the decimal, move it 2 places to the right if you want to deal with cents. And you can go back and figure out why that is later on, but now we just have to figure out how to do the problems. So there we go. That's it. That's how you do these change problems. They're pretty much going to be all the same. So we're going to multiply the top equation. I'm going to eliminate n, multiply the top equation by -5, and just rewrite the bottom equation. Now we can add the equations together and we get 20q. And we can use the calculator for that. 560 minus 180 is 380. And divide both sides by 20. And we get 19. So there are 19 quarters. And then we can use the blue equation to figure out how many nickels there are. Nickels plus quarters is equal to 36. Subtract 19 from both sides, and we get 17 nickels. So again, that's how you do these change problems. So let's do another one of those together before you try some on your own. There are nickels and dimes in a bag this time. The total number of nickels and dimes is 15, so on and so forth. Total value is $1.05. Same problem. We're just dealing with dimes now. So n is the number of nickels. And d is the number of dimes. And let's do the easy equation first. There are 15 nickels and dimes. So the number of nickels plus the number of dimes must be 15. That's the easy equation. Now we'll go to the hard equation. The amount of money is $1.05. So again, 5 cents times the number of nickels plus 10 cents times the number of dimes. Dimes are 10 cents each. Equals 105. Not 1.05. It's 105 because we're dealing in units of cents, not units of dollars, because we want to avoid those decimals if we can. All right, so it's going to be, let's see here, I can eliminate D or I can eliminate N, but I want to use the smaller numbers, so I'm going to multiply both sides of the top equation by -5. And now I can eliminate. Divide both sides by 5, and we get 6 dimes. There are 6 dimes. And obviously, if there are 6 dimes, then there are 9 nickels. So now it's time for you to try one of those problems. You can take a screenshot of these if you want to refer back to them. So try 21, and when you come back, we'll do it together. All right, we're back. How many of each type of coin does she have in her purse? So obviously Q is going to be the number of quarters, and D is the number of dimes. Again, you must write this. I know it's tedious to have to keep writing the definitions of your variables, but you have to do that. It's the most important part of the problems. And try to write legibly, unlike me. All right, so we generate our system. There are a total of 16 coins. Number of quarters plus number of dimes is equal to 16. If the coins are worth $2.05, so again, we're using units of cents. And you must move the decimal 2 places if you're going to use units of cents. So we get 205. Multiply the top equation. I'm going to eliminate D. Multiply the top equation by -10, and add the equations. We get 15Q is equal to 45. Divide both sides by 15, and we see we have 3 quarters. So if you got 3 quarters, good job. And if you have 3 quarters, obviously, you're going to have 13 dimes. So if you got those answers, good job. Again, this is a very common problem, these coin problems, so try number 22, and when you come back, we'll do it together. All right, we're back. How many of each coin did he find? And we're dealing with nickels and quarters. Let's look for the easy equation. That would be, he found 11 coins at the beach, and 5N plus 25Q is equal to 195. Multiply the top equation by -5, and we get 20Q. Add them together, we get 20Q is equal to 140. Divide both sides by 20, and we see that we have 7 quarters. And obviously, if we have 7 quarters, we have 4 nickels. So if you got those answers, good job. Again, in those problems, we were just looking for numbers of things, numbers of coins. All right, the last problems we're going to do today are called mixing problems. Dr. Peterson wants to prepare 12 ounces of an 8% saline solution, a mixture of salt and water, but in her lab she has access to only 4% saline solution and 10% saline solution. How many ounces of each solution must she mix to produce her desired result? So this problem seems somewhat complicated. So let me explain the general idea by drawing a picture. You have a 4% solution. That means 4% salt and the rest is water. And you have a 10% solution. 10% is salt and the rest is water. And what you're going to do is you're going to take some of the 10% solution and you're going to pour it into a third container. And you're going to take some of the 4% solution and pour it into that third container to create 12 ounces of an 8% solution. So that's what's going on here. So I know that seems a little complicated, but once you get the idea of how to do these problems, it's going to be pretty easy. Alright, so as usual, we're going to start with defining our variables. How many ounces of each solution must she mix to produce her desired result? So that tells us that we need ounces, and I'm going to write V for volume, because ounces is volume. So volume of the 4% solution, that means 4% salt. And V10 is going to be volume, obviously, of the 10% solution. And I should say ounces. Now we're going to look for an easy equation. Dr. Peterson wants to prepare 12 ounces. So that's the easy equation to deal with. So V4 plus V10 is equal to 12 ounces. And now comes the hard part. So the other information is going to give us obviously the next equation. Now the next part, it's not hard to understand the general concept, but I just want you to be aware that when it comes to mixing liquid, some of these problems require knowledge of chemistry. And you'll find that some of these problems, it's difficult to figure out if you're dealing with volume or mass or a combination of the two. And sometimes when you take a solid substance, in dry form, the volume of the substance changes when you dissolve it into a fluid. So the concepts here are really more complicated than the authors of this problem are trying to portray it. So I just want you to be aware that, in my opinion, it's really not fair to give students this type of problem because of the issues that arise when you're dealing with mixing fluids and solutes together. But I'm just giving you this problem because there's a good chance you may see it, and as long as you understand the general concepts, you're not really going to need to know the details of the chemistry, because chemistry is not really a prerequisite for this course. But we're going to need to remember how to find the percent of a number. So if you want to find, for example, 15% of 36, recall we learned in my arithmetic course, or you should have learned in some arithmetic course that you took, to do this you change the percent to a decimal. So you move the decimal 2 places over, and then you multiply that number by, or that decimal by the actual number. So 0.15 times 36, and whatever that ends up being, that's 15% of 36. So we're going to need to use that knowledge. What we're going to do is we're going to change 4% to a decimal, and then we're going to multiply it into V4, and that's going to give us the salt that's in the 4% solution. And then we're going to do the same thing for the 10% solution. That's going to give us the salt from the 10% solution. So we're going to take the salt from the 4% solution and add it to the salt from the 10% solution, and that should equal the salt in the total solution, or the final solution. So to find the salt in the final solution, we know that it's going to be 8%, and there's 12 ounces total. So we just find 8% of 12, that's the salt in the total salt in the final solution. So again, that's really important. The salt in the 4% solution, because it's not all salt, it's salt and water. This equation deals with salt and water. But the bottom equation deals with only salt. So the salt in the 4% solution plus the salt in the 10% solution equals the salt in the total solution. That's the hard part. It's hard for two reasons. One reason is you're trying to find a percent of a number, and a lot of students really find that to be a confusing concept. And the second reason it's difficult is because some of these concepts don't even really apply in the real world, because again, the chemistry becomes difficult when you're dealing with mass and volume at the same time, or you may not know if you're dealing with a mass or volume. It seems as though we're dealing with volume, but you'll find that that's not really true when you talk about saline solutions. So anyway, at this point, all we have to do is just solve the system. So I'm going to go ahead and simplify the system. Because we have 0.08 times 12, we need to actually do that calculation. So I'm just going to copy and then 0.08 times 12, we can do that on the calculator. 0.08 times 12 is 0.96. All right, so now I'm going to multiply. I think it'll be easier to get rid of V10, so I'm going to multiply the blue equation by negative 0.1 and remember, for 0.10 I don't have to put the 0, I can just put 0.1, and we multiply by 12 and you get negative 1.2. And let's see here, just double checking that seems right, and we're just going to rewrite the bottom equation. And now we're ready to eliminate. And I'm going to move this over to give us a little more room here. I'm actually going to take this equation and move it up. These are the benefits of having a digital notebook. And now we're ready to eliminate. Let me color code first. And negative 0.1 V4 plus 0.04 V4 is negative 0.06. And we'll put an arrow. So we're ready to eliminate. So we add the equations together. And 0.96 minus 1.2 is negative 0.24. Divide both sides by negative 0.06. And we get 4. So the volume of the 4% solution we're going to need to use is 4 ounces. We'll put OZ for ounces. So now we can just use the blue equation. I guess I could try to use an arrow. So V10 is obviously just going to be 8 ounces. So if we use 8 ounces of the 10% solution and 4 ounces of the 4% solution and pour them together, we get a total of 12 ounces of an 8% solution. So let's try one more of these before you try one on your own. 3 karat gold is 12.5% gold. 12 karat gold is 50% gold. If a metallurgist has only 3 karat gold and 12 karat gold, how many grams of each purity should he melt and mix to create 12 grams of 6 karat gold, which is 25%? So again, it's the same type of problem. You're just taking two things and mixing them together. So the first thing we do is figure out what our variables are going to be. How many grams of each purity. So I'm going to write G, because now we're finding mass. Grams is mass, so G, I'm going to write G for grams. Actually, you know what? I'm going to write M for mass, because we wrote V for volume last time. So mass of the 12.5% gold, or I'm going to say substance. And of course that's in grams. And then M50 is obviously the mass of 50% substance grams. Again, that's the most important part of these problems. So now let's look for an easy equation. We want 12 grams. So that's going to be the easy equation, M12.5 plus M50 is equal to 12. So again, that was all the easy part. If you're going to complain about the difficulty of this problem, that's okay, but you don't complain until you write all this down first. This is all the easy part. So now we're going to take 12.5% of the mass of the 12.5% gold. So this is the gold inside the 12.5% substance. And we're going to take the gold in the 50% gold substance. And we're going to add that up. So we're just, the bottom equation is just talking about gold. This is talking about the gold and the other metals inside it. So it's talking about all the metals. But this equation is just talking about only the gold. So we're trying to take the percent of the mass that's actually gold. And that should equal the total gold in our 12 grams. So we take 25, because this is 25%. So our final substance should be 25% gold. So we take 25% of the total number of grams. So this is the total amount of gold. So the amount of gold in the 12.5% substance plus the amount of gold in the 50% substance, and we get the total amount of gold. And when I say 12.5 and 50, I mean obviously 12.5% gold and 50% gold, so on and so forth. So again, that's the hard equation. The other parts are fairly easy. Let's see here, that should be green there. All right, and so now we just have to solve and we'll be done. So, as in the previous problem, I'm just going to rewrite this equation and simplify and find 25% of 12. %25 of 12 would just be 3. So that was easy. So now I'm out of room, so I'm going to have to do an arrow to go up here. And I'm going to multiply. I think I'm going to try to eliminate M50. So I'm going to multiply both sides of the blue equation by negative 0.5. And we get negative 6 on the right side of the equation. 12 times negative 0.5 is negative 6. And so that's the blue equation. I'm just going to rewrite the green equation. And so now we can eliminate, add the equations together. And negative 0.5 plus 0.125. That gives us negative 0.375 M12.5. And of course these cancel out. And negative 6 plus 3 is negative 3. So now negative 3 divided by negative 0.375. That gives us 8. And we can write G for grams. Lowercase g is the unit for grams. Or you can just spell out grams if you don't know what the abbreviation is for that mass. So 8 grams, and we can look back to the original blue equation to figure out how many grams of the 50%. And obviously that would just be 4 grams. Because 8 plus 4 is 12. So it turns out that the answers to these first two problems were the same. But that was just a coincidence. Alright, so you can take a screenshot of those problems if you want to refer back to those, because it's time for you to try a problem. So try number 25, and when you come back, we'll do it together. Alright, we're back. So this is a fluid problem, so again it has the issues I was talking about, but you don't have to think about those issues. You can just use the same concepts we use, the general concepts. So we always start out with how many milliliter, or what are our variables going to be. So let's say volume of the 3% solution is V3, and that would be in milliliters. And of course V12, and that, if you don't know, that's just the abbreviation for milliliters. I'm just trying to save room. Alright, so we got that part done. So now let's go to the easy equation. Vivian wants to make 36 milliliters. So 36, so the volume of the 3% acid solution plus the volume of the 12% acid solution should be 36 milliliters. And now comes the hard part. We want 6% hydrochloric acid solution. She has 3 and 12% solutions. So the acid in the 3% solution plus the acid in the 12% solution is equal to the total acid in the final solution. And we know it's going to be a 6% solution, so 6% of, and the total is going to be 36 milliliters, so 6% of 36 milliliters should be the total amount of acid in the final solution. Again, it's just the same thing that we did before. So first step, we'll just simplify 0.06. So we have to calculate 0.06 times 36. So 0.06 times 36. You can get the calculator for that. 0.06 times 36 is 2.16. So now we've got standard form equations, which means there's no variable isolated. We have to use elimination. So I'm going to multiply the top equation. Let's see here. I'm going to eliminate V3. So I'm going to multiply the top equation by negative 0.03. And 0.03 times 36 is, it would be negative 1.08. And of course we can just rewrite the green equation. Alright, so now we're ready to eliminate. And here we've got 1.08 and 0.09 V12. V3's cancel out. And 1.08 divided by 0.09 is 12. So we're going to have 12 milliliters of the 12% solution. That's just a coincidence that it ended up being the same percentage. And then we can use this blue equation and just plug in 12 for V12. We didn't do this in the last problem because the last two problems we just didn't have enough room. So obviously V3 is equal to 24 milliliters. So if you got those answers, good job. Alright, so now I'm going to leave that problem in the window, and I want you to try number 26. And Number 26 is going to be like the metal problem. It's a solid, it's not fluid, so we don't have the same issues when it comes to understanding. So try number 26, and when you come back, we'll do it together. All right, we're back. Let's see how many kilograms of each type of concrete. So mass of 10%, mass of 14%. I'm going to say substance, and of course it's in kilograms. The abbreviation for kilograms is just kg. Again, that's the most important part. So now let's look for an easy equation. He wants to create 32 kilograms of a concrete. So that means the mass of the 10% concrete cement and the mass of the 14 cement adds up to 32 kilograms. So again, these problems may be intimidating, but that's no excuse for not at least writing these first parts that are really easy. Alright, so here comes the hard part. We're going to take 10% of the 10% cement substance, and so that's all the cement in the 10% concrete, and then we're going to add all the cement in the 14% concrete, and that's going to equal the total amount of cement in the final substance, which is 0.134 times 32, because that's the total mass in the final mixture. So as usual, we'll just simplify the green equation. 0.134 times 32, and we get 4.288. So all we did was just simplify that green equation. Now I'm going to eliminate the M10. I think that would be easier. So we're going to multiply the top equation by negative 0.1 and rewrite the bottom equation. Now we're ready to eliminate. And we get 0.04 M14. And let's get the calculator out for that. 4.288 minus 3.2 is 1.088. Divide that by 0.04. And the mass of the 14% cement concrete is 27.2 kilograms, so you can write kg. So now we just use this blue equation up here to find the mass of the 10% cement concrete. Just plug in 27.2. So 32 minus 27.2. So we got those answers. Good job. Alright, so now we're going to combine mixing problems with money problems. So let's do a couple of these together. Lemonade concentrate costs 50 cents per ounce. Water costs 10 cents per ounce. How many ounces of each ingredient are necessary to make 16 ounces of lemonade that costs 27 cents per ounce? So this is a problem that's dealing with fluid. So it doesn't really make a perfect sense in the real world, again, but I'm just going to show you how to do this problem. And again, the reason it doesn't make sense is because the volume, ounces are, that's volume. The volume of a solid substance doesn't necessarily, it is not necessarily the same when you put it into a solution. But same situation, how many ounces of each ingredient are necessary? So that's what's going to define our variables. So volume of the water is going to be VW, and VC is going to be the volume of the concentrate. All right, so let's look for the easy equation. Make 16 ounces. So VW plus VC is equal to 16. And for the other equation, we have the same situation, but now we're dealing with money. So this next equation is not going to be lemonade concentrate. It's not going to be the same thing as the other problems. This next problem is going to be money. This is just volume of the combination of the two substances. It's a volume. But this equation is going to be about money. So what we're going to do is we're going to take the number of ounces of water, and we're going to multiply it by the price per ounce of water. So it's 10 cents for 1 ounce. So again, the volume of the water, the number of ounces of the water times the price per ounce. That gives us the amount of money that we're going to pay for the water. So this is the amount of money we're paying for water. I should go ahead and write that over here. So money paid for water, and the lemonade concentrate is 50, so 50 VC is the money paid for concentrate. So we're going to take the money paid for water and we're going to add it to the money paid for the concentrate. And that should equal the total amount of money that we're going to pay for the total, for the final substance. So we know that the final substance is going to be 27 cents per ounce, and there's going to be 16 ounces. So take the total number of ounces and multiply it by the price per ounce of our final substance, and you get the total amount of money. And you get the total amount of money we're going to pay for the final mixture. All right, so we'll just simplify it. We'll do 27 times 16. So 27 times 16 for 32. So now we're ready to eliminate. I'm going to eliminate VW, so multiply the top equation, the blue equation, by -10. And now we're ready to add those equations together to eliminate VW. And we get 40. 40 VC is equal to 432 minus 160, which is 272. Divide both sides by 40, and VC is equal to 6.8 ounces. So we need 6.8 ounces of the lemonade concentrate. And then we can just take our blue equation, volume of the water, plus plug in 6.8 for VC. 16 minus 6.8 is equal to 9.2. So 9.2 ounces of water. So we're going to add 9.2 ounces of water to 6.8 ounces of concentrate to make 16 ounces of a solution that costs 27 cents per ounce. All right, we'll try one more of these together before you try some on your own. Metal A costs $28.25 per kilogram, while metal B costs $25.50 per kilogram. If the metals are mixed to form a 90 kilogram alloy, how many kilograms of each metal are necessary to make the alloy cost $27.70 per kilogram? So in case you don't know, an alloy is just a mixture of metals. And let's call it, let's say that A is the mass of metal A in kg kilograms, and B is the mass of metal B in kilograms. And again, if you don't know these abbreviations, you don't have to use them. You can just say kilograms. All right, so that's the most important part we got out of there. And let's look for an easy equation. So the easy equation is if the metals are mixed to form a 90 kilogram alloy. So that means that A plus B is equal to 90. The number of kilograms of metal A plus the number of kilograms of metal B is equal to 90. And metal A costs blah, 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 so on and so forth. So I need the rest of the information. So we take the number of kilograms of metal A and we multiply it by the price per kilogram. And that gives us this number, this here gives us the amount of money that we're going to pay for metal A. And then we add that to the amount of money we're going to pay for metal B. And we don't really need that extra zero there. And that is equal to the total amount of money for 90 kilograms of the final alloy. So that's going to be 27.7 per kilogram, and then there's 90 kilograms. So this is the total amount of money we're going to pay for our final alloy, because we know it's $27.70 per kilogram, and we know there's 90 kilograms, so we multiply those. So now we just have to solve the system. So now we're just going to simplify. 27.7 times 90. We'll do that in the calculator. Is 2,493. And I'm going to use elimination as usual, because these equations are all in standard form. So I think I'm going to try to eliminate B. And 25.5 times 90 is 2,295. And so now we're ready to add the equations. Oh, yeah, we need a negative. We need a negative on that 2,295. So now we're ready to add up. So again, you can use the calculator for this. 2,493 minus 2,295. We get 198. And 28.25 minus 25.5 is 2.75. And we're out of room, so we can just go up here, divide both sides by 2.75, and we have 72. So the mass of metal A is 72 kilograms. And then we can just use the top equation. plug in 72. And obviously the mass of metal B that we're going to use would be 18 kilograms if you subtract. All right, so now it's time for you to try. There's 2 more problems today, so all you have to do is finish 29 and 30 and we'll be done for this class. All right, so try number 29, and if you want, you can take a screenshot of these so you can refer back to those. So try number 29, and when you come back, we'll do it together. All right, we're back. So first step, what are we looking for? Define our variables. How many pounds of each ingredient? So we have, what do we have? Peanuts. So P will be the number of pounds of peanuts. And what else do we have? What is it? Candy. So C will be the number of pounds candy. So that's the most important part, is to define those variables. If you don't do that, you're just going to be completely lost. All right, so now let's look for the easy equation. We want 20 pounds of trail mix. So the number of pounds of peanuts plus the number of pounds of candy should be 20. And so now we go to the more difficult equation. So it's $4 per pound for the peanuts. So $4 times the number of pounds of peanuts plus $15 per pound for candy times the number of pounds. So this is the amount of money you're paying for peanuts plus the amount of money you're paying for candy is equal to the total amount of money you're paying for the mixture, and it's $9 per pound for the mixture, and there's 20 pounds. All right, so let's just simplify. We'll rewrite the top equation, and 9 times 20 is 180. So we're going to multiply both sides of the top equation by -4, and now we can eliminate, and we get 100 and 11C. So divide both sides by 11 and we get a repeating decimal. The number of pounds of candy is 9.09 bar. And we'll write pounds, LBS. So that's one answer. Make sure you write that arrow. And then we can take that number in your calculator, if you still have that number, and you can subtract, do -20, and you're going to get a negative number, but you can just take the negative number away. And so plug in that, just to show the algebra, we'll plug in the 9.09 bar. Because, you know, it's impossible to write an infinite number of 09, so you want to try to keep that in your calculator if you can. And then we end up with number of pounds of peanuts is 10.90 bar pounds. So that was the first time where we got repeating decimals for the answers. So I'm sorry if that confused you there, but if you got those answers, good job. All right, so last problem. Try number 30. When you come back, we'll do it together. All right, we're back. First part of the problem, define variables. How many pounds of each ingredient? So what do we have here? We have soil and we have fertilizer. So let's let S equal number of pounds soil, and F will let equal the number of pounds of fertilizer I'm just going to condense that. All right. Again, that's the most important part of the problem. If you didn't do that, you're not going to be able to go anywhere in this problem. So now let's look for the easy equation. So we want to produce 20 pounds of the mixture. So S plus F is equal to 20. And the soil sells for $2.75. So we multiply that by number of pounds of soil, and that gives us the amount of money we're going to pay for the soil. And then the fertilizer sells for $11.75, so we multiply that by the number of pounds of fertilizer, and that'll give us the amount of money we're paying for fertilizer. And the total cost for the mixture of fertilizer and soil should be 9.05, because that's how much each pound costs, times the total number of pounds. So now we can just simplify. And 9.05 times 20 equals 181. And everything looks right. So now I'm going to eliminate the S. Multiply the top equation by negative 2.75. 2.75 times 20 is negative 55. 181 minus 55 is 126. And 11.75 minus 2.75 is 9. 126 divided by 9 is 14, so we're going to buy 14 pounds of the fertilizer. And use the top equation, plug in 14 for F. Subtract 14 from both sides, and the number of pounds of the soil is going to be 6. So if you got those answers, good job. I forgot to color code. Forgot to color code on this one too. I think you get the point. This is all the work that we did today. If you'd like to take screenshots of these pages to help you with your homework or to study for tests, go ahead and do that now. Now don't go before you get your homework. Get a screenshot of these first 2 pages. And get a screenshot of these last 2 pages. Notice you have the answers. But again, you need to do it exactly the way I did it in the class today. You need to define your variables, show what each letter represents. Then you need to write your system of equations and show the steps where you transform the system into something else, or with the substitution rule use or plug something in. Whatever the work is that you need to do to figure out the answer, you need to show that. And then remember, write your units for the final answer, rectangle your answers, so on and so forth. This is just all basic stuff that you need to do for every math course. And remember to write the name, your name, the date, the course title, which is beginning algebra, a title for the paper, which is just going to be what you see here. You can just copy that down pretty much. And remember, if you don't do the homework, then it's a 100% guarantee you're going to learn absolutely nothing in this entire course. And your homework needs to fit those 4 characteristics. It has to be complete, it has to be correct, it has to be neat, and it has to be in order in your binder. If your homework doesn't fit one of those 4 characteristics, then it's a complete waste of time. So get that homework done, and I'll look forward to seeing you in the next class.